to sign up. And this is the API key you'll need to bring.
And for those on the Zoom who didn't hear because we were muted, please sign up with this QR code. Thank you.
Distribute the drinks.
I just can't think about all
Can you
that.
move your laptop off?
Yeah.
And if anyone wants to grab a drink, please grab it.
I'll go with the aisle. Get some. Make it a little bit easier distribution wise. Definitely in the comment. All right, did everyone sign up with the QR code?
So are we good? Let's get started. Go for it.
All right, so let me just go all the way back. Okay, so today we're going to be starting with how to build your own deep research. So show of hands, how many people know what deep research is who have used like Claude or ChatGPT's deep research? Okay, only a few people. All right, perfect. Okay. So here is what you're going to get out of this workshop. So first of all, you're going to get free API credits through Cerebras platform and through Exa, which is an AI web search tool. You're also going to get a quick start to build apps with Cerebras and Exa, so that if in the future you want to continue working on apps and projects like this or using our technologies, you can do that as well. And then you're also going to get your own version of research chat, so you're not limited to the 10 queries that ChatGPT offers you. So here's just kind of a quick little demo of what deep research is. Well, that went great. Okay. Let's see, can we get the... Okay. I don't know why the video is not playing. Okay. So what this essentially is how many of you have heard of Perplexity? Anyone? Show of hands. Yeah. They're a big company right now. And essentially what they do is basically just AI powered Google. See, because Google is great if you have a question like what color is the sky or why is the sky blue or something. But if you want to know something more specific or just have a more general query, then simple yes, no, white, black, red or yellow answers are not going to get you there. So that's why things like AI tools can speed things up a lot, because you can give it a general query like, how can AI help solve climate challenges? And instead of needing to go through numerous links yourself on Google or Yahoo or any other search platform and just compiling the results manually, it will use LLMs to essentially accelerate the process. So just like back in 3rd grade, you know, when you had to write those little reports about like climate change or the solar system or whatever, this will just essentially allow LLMs like ChatGPT, Llama, etc., to just do it for you. So how is deep research traditionally done? Right? Because we know how people do it, but how do LLMs do it, right? How do you get an LLM to go and visit all of these sites and gather all this information? So this is the flowchart right here. So you start with a research question, and you're going to split it up into a few different kind of like methods of search, right? So you've got library, Google search, and interviews, for example. This is how human might do it, right? So then you would just go and you'd take notes, like, for example, climate change, right? In a book, you would read like, oh, it happens because of, you know, carbon trapped in the atmosphere. For Google, you'd also get information there, and you'd also accrue information from interviewing potentially like experts in the field or professors or whatnot. You'd take notes, and then you would compile these notes into an answer. So now AI-powered deep research, this is a more automatic process, right? Because when you're doing it yourself, you have the freedom to say like, this doesn't make sense, I shouldn't include it, this does make sense. But when you're telling a program to do it itself, it's going to be a little different. So it's going to be like, it's going to look the same, but the way that you actually carry it out is a little different, right? We've got web search, retrieval augmented generation, and then the LLM step. So essentially, web search is going to be the same as if you're doing research yourself, right? It's going to be compiling a list of sources, a list of links from the internet. Now we get to a step called RAG, or retrieval augmented generation. And this is something, basically, an LLM like ChatGPT or whatnot, they're not going to take in the raw content of all of this text, right? It wouldn't be feasible to pass up to like 40 or 50 different links to ChatGPT. So instead, what it does is there's a special algorithm that's going to go through and using vector similarity, kind of take the most important pieces of all of those sources and compile it into one thing called a summary. And that's what retrieval augmented generation is, right? Because it's retrieving the important information, also sometimes a summary, from a web page or a series of web pages and aiding the LLM in generation. So for example, if I am writing a Wikipedia article on climate change, then RAG is going to take in a long list of URLs with potentially overlapping information and just kind of give you the bullet points. So as we mentioned earlier, deep research is perfect for complex queries, large volumes of material, again, because it's automated and you can process it so much faster than if you're going through it yourself. Keeping up with fast-moving fields, again, because it's able to index the internet very quickly, and then creating summaries or reports. All right, so everyone, please go ahead and scan this QR code, and this will open the starter code inside of a notebook. Give you a second to do that. We got it?
Once you're able to access the starter code for this workshop, and we'll wait till everyone is basically. We have a few more minutes. In the meantime, you can also go ahead and start reading through the starter code, but kind of just get them and to kind of read ahead on what we're.
All right, can we see another show of hands? Does everyone have it? I'll give you a few more seconds. Okay, so first step is going to be installing the required packages. So you're going to have to head over to exa.ai and cloud.cerebras.ai to get these API keys. And so these are required to use the services. They're both free, by the way. You're going to have enough usage to be able to complete the notebook and do some side projects if you'd like. And then just go ahead and set these environment variables as well. So Cerebras is the inference, so the LLM here, while Exa handles both the web search and the retrieval augmented generation step. I'll give you another few minutes for that.
While you're doing that, quick show of hands, who had heard of Cerebras before this event? Okay, good. Guess you're aware of that.
All right, can I also see a show of hands when you've set up both API keys, please? All right, can I get another show of hands? Everyone have both API keys? I'll give it a few more minutes.
What's the usage limit for Cerebras and that? Is it like monthly or is just like you get a batch of blue credits?
So we offer up to 1 million free tokens per day per model. You're going to also be limited by minutely limits. So if you use a certain number of requests or tokens per minute, then you'll be limited. And then after that, it goes to hour and day are the same, I believe. But yeah, it's 1 million input and output combined. So that's for GPT, OSS, Llama, Quen. You get 1 million per model. Yeah, good question. And then Exa, I believe it's up to $5, but I think there's some quick starts on their page where you can get more than that if you're looking to do a personal project with it.
So I think that's. Oh, is that? Oh, sorry, yeah, I think that's.
I'll give it one more minute. Okay, everybody ready? All right, I'm seeing some hands, so I'm going to go ahead and change the slide. Okay, so first we'll just start with what Cerebras is. So if you haven't already, I mean, you already have API keys, but you can find the QR code again. And so basically what we do is we are the fastest inference provider in the world. So we run Llama models like Llama, MetaLlama, Alibaba, Quen, OpenAI's GPT OSS models, and more, all about 50 times faster than NVIDIA GPUs. The way we do this is the wafer scale engine. So basically, instead of just the wafers and GPUs, which are about the size of your thumbnail, our chips are bigger than your head. And as you can see for the throughput, so basically the generation speed, we're getting closer to 3,000 tokens per second, while most of the GPU providers are limited to below 200. You can also see Grok up there. They're another custom chip. Okay. So Exa, to give more information on what Exa is and how it's used here, is Exa basically is, as mentioned previously, is both a RAG tool and a search tool, just pretty much like to give LLMs context for the web. So they've got a couple endpoints. They have search, contents, answer, and research. All of these are just various functions that help your LLM connect to the web and gather information. You can choose to automatically summarize it. You can choose to automatically, create bigger reports out of them, or you can just get the raw content. Let's go here. Yeah, and so here we use Exa, of course, for these first couple, which is, calling the web search itself and then the RAG part. Well, Cerebras handles the LLM step at the bottom. Okay, so in the notebook, you're going to see a function called search web. And so this is going to use Exa's search and contents function. And so when we say type auto, that's going to be both a semantic search and a keyword search. So what this means is, say, for example, let's go back to the climate change query. If your query is how does AI affect, efforts to reduce climate change and keep the climate healthy, then Exa is going to go out and it's going to find a bunch of queries related to climate change and AI and climate change, both based on the keywords AI, climate change, and such, and then also the semantic meaning. So for example, if you're talking about increased levels of pollution due to machine learning, that's going to be semantically matched with the query because they both really mean very similar things. And then of course we have some parameters like num results and text, which you can customize depending on how much content you want the function to bring in. So this is an example of some of the different sources that you might get to Exa. Okay, so step 3 is analyzing the response, right? Because you have all of this content that you're bringing in from Exa, but you also now need to feed it to an LLM in order to actually generate the deep research or start generating it. So that is going to begin with our Ask AI function, which is pretty standard. It's just a kind of a basic inference call to Cerebras. So our prompt, for example, would be based on these forces, provide a comprehensive summary, and so on, and basically asking our agent to review all of the data that's kind of being dumped from the Exa search and just format it into a report that is readable by a person. Okay, so this is kind of a basic research flow, right? Because we start with a research question, and then we're going to get RAG using Exa's web search, and then we're just going to summarize it, right? So if you've ever used ChatGPT's research, you're going to notice that it takes about 15 to 20 minutes. And the reason for that is because they're not just doing this. There's a little bit more complexity to it, right? Because what this is a very linear path that is web search, retrieval augmented generation, and then just summarization, essentially. Right? So you can see that more graphs of this here. There's a deeper, kind of more advanced research where you actually have multiple steps in between. Instead of just one web search and one LLM call, you can have a setup, for example, where you have the LLM summarize it and then more web content be imported and the LLM summarize it there. You kind of like, for example, if you're researching climate change and you find something that might change the direction of your research, it would be valuable to have input from the AI at a certain point throughout that research. So that's kind of how we expand the project. So for example, Anthropic, the creator of Claude, one way that they control their deep research is after the research question is initially generated, instead of just getting RAG and putting it through an LLM, what they do instead is they will split it into multiple different sub-agents, which are all kind of reporting to that main LLM. So what this main LLM will do is it'll say, okay, AI and climate change. First thing we're going to give to like LLM number 1, the task that we're going to give them is, okay, understand how AI is affecting climate change for, let's say, recycling, right? And LLM number 2 is going to get a different task. It's going to get a different thing to explore. So each of these are each going to follow their own kind of paths inside of this query. So breaking down the task into different subtasks. Then at the end, a large language model will kind of aggregate these results into one thing. So, for example, if you use Claude Deep Research, that's exactly what you'll find it doing. You'll find it kind of tracing multiple different paths, and based on those paths, sometimes this end model will actually call more subagents itself. Okay, yeah, thank you. So if you, is everyone on the Colab notebook right now? All right, any issues with that? Okay, perfect. Yeah, so that's kind of how you get started with Cerebras and Exa. If you have any questions about how to use either of them, just let me know. But yeah, try to get that running. It should by the end of it give you kind of like a more like a pathway to a little bit more advanced deep research. So there will be like the kind of multi-agent thing that we talked about, where it's dividing the task into multiple subagents. Yeah, any questions right now?
All right,
Thank you.
can we get one more round of applause for Cerebras, guys? All right, that concludes today's HackWeek workshop.